Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Before electricity lit our cities, before natural gas pipelines reached homes, there was another fuel that changed the night forever: coal gas. In 1792, Scottish engineer William Murdoch experimented with distilling coal and used coal gas to light his cottage and offices in Redruth, Cornwall. That small experiment became one of the earliest practical uses of coal gas lighting, decades before modern electric grids. But today, coal gasification is no longer about street lamps. Today, it is a high-pressure, high-temperature industrial process that can turn solid coal into syngas, a mixture mainly of carbon monoxide and hydrogen, which can then be used to produce electricity, hydrogen, methanol, ammonia, synthetic natural gas, fertilizers, and liquid fuels. The U.S. Department of Energy describes gasification as a process using heat, pressure, and steam to convert carbon-based raw material into syngas. This is not ordinary coal burning. This is controlled chemical engineering inside one of the harshest reactors in industry, the coal gasifier.
Part 1. What is coal gasification? In a normal coal-fired boiler, coal is burned completely with excess air. The goal is simple: release heat. But in coal gasification, engineers do something very different. They supply limited oxygen and steam. Instead of fully burning the coal into carbon dioxide and ash, the coal is partially oxidized and chemically broken down into useful gases. Inside the gasifier, oxygen and steam contact coal in a high-temperature, high-pressure vessel. The major product is syngas, mainly carbon monoxide and hydrogen. In simple words, coal gasification is the engineering process of converting solid coal into a flexible gaseous raw material. And that gas can go in many directions. It can be burned in a gas turbine. It can be shifted to make hydrogen. It can be converted into methanol. It can be used to make ammonia for fertilizer. Or it can be upgraded into synthetic natural gas. That is why coal gasification is often called a bridge between coal mining, chemical engineering, power generation, and fuel production.
At the heart of the plant, everything depends on a few powerful reactions. First, a small portion of coal reacts with oxygen. C plus O2 becomes CO2 plus heat. This chemical reaction releases a significant amount of heat. Then another reaction forms carbon monoxide. C plus half O2 becomes CO plus heat. This also releases heat, but instead of complete combustion, it creates useful carbon monoxide. Now steam enters the chemistry. C plus H2O becomes CO plus H2. This is called the water-gas reaction. It produces the two most important syngas components, carbon monoxide and hydrogen. Another reaction is the Boudward reaction. C plus CO2 becomes 2CO. And if more hydrogen is needed, the plant uses the water-gas shift reaction. CO plus H2O becomes CO2 plus H2. This is extremely important in hydrogen and ammonia production. The gasifier is not just a furnace, it is a chemical reactor, where temperature, pressure, oxygen flow, steam flow, coal particle size, ash behavior, and residence time must all be controlled. One wrong balance can produce too much soot, too much slag, poor carbon conversion, unstable flame behavior, or dirty syngas. Main sections of a coal gasification plant. A coal gasification plant is complex but logical. It consists of 7 major sections. 1. Coal handling and preparation. Coal is crushed, dried, and pulverized to ensure a continuous, pressurized feed into the reactor. 2. Air separation unit. By cooling air to separate high-purity oxygen, we avoid diluting the syngas with nitrogen, making the process more efficient. 3. The gasifier. Here coal reacts with oxygen and steam at up to 1,600 degrees Celsius, transforming into raw syngas and molten slag in seconds. 4. Syngas cooling. Extremely hot syngas is cooled rapidly to recover heat, often generating steam for power or internal plant use. 5. Gas cleaning. Contaminants like dust and sulfur are removed from the pressurized stream, a key environmental advantage over traditional combustion. 6. Gas conditioning. The clean syngas is adjusted through shift reactions to match the specific needs for hydrogen, methanol, or ammonia production. 7. Product section. Finally, syngas becomes electricity in an IGCC plant or a vital chemical feedstock. This flexibility is the real power of gasification. Coal is no longer just burned. It becomes a versatile chemical building block.
Environmental reality coal gasification is often called cleaner than direct coal combustion. But we must understand this clearly. It does not magically remove carbon. Coal is still a carbon-rich fuel. If carbon monoxide is shifted to hydrogen, carbon dioxide is produced. If syngas is burned, carbon dioxide is produced. So without carbon capture, coal gasification still has major CO2 emissions. The advantage is different. Because gasification creates a concentrated, pressurized process gas, pollutants and CO2 can be removed before final combustion or product synthesis more easily than from a large diluted flue gas stream. MIT notes that one motivation for IGCC is better environmental performance, especially for mercury removal and CO2 capture. So coal gasification should not be presented as zero emission. It is better described as a more controllable and flexible coal conversion route. Its environmental value depends on gas cleanup, water management, sulfur recovery, CO2 capture, ash handling, and final product use.